Okay, so new chapter start કરીએ છીએ આપણે lacing, battening and slab base, right? So starting with this introduction of lacing, battening, right? So typical joining of components is done by these two ways. First one is lacing and battening. So lacing bar or metal plates are not designed as a load carrying members. They carry only transverse shear forces which occurs when the column defects, right? So here the figure shown in this figure, this cross is provided which is lacing, right? Lacing and battening, which is also not designed as a load carrying capacity but as a support member, or which it transfers the shear force which occurs when the column defect, right? So it prevents reflections in a column or such buildings, right? So there are two types of lacing system, but we know one is a single, as shown in figure, there is a single lacing system provided, and in the second figure, double lacing system is provided. So basically, the lacing system should not be varied throughout the length of the strut as far as practical, right? So single lace system on opposite sides of the main component should preferably be seen in the same direction so that one system is the shadow of the others. So cross or accept type plate should not be provided along the length of the column with lacing systems unless all the forces resulting for deformation of column members are calculated and provided for in the lacing and its fastening, right? So basically, a lacing system should generally conform to the following requirements. So there are some requirements while designing the lacing system, which is the compression members comprises two main components. The two main components, laced and tied, should where practicable have a radius of gyration about the axis, which is perpendicular to the plane of lacing, not less than the radius of gyration at the right angles to that axis, right? Second one is the lacing system should not be varied throughout the length of the strut as far as possible. So એ basically એમ કહે છે કે તમારી જે લેસિંગ સિસ્ટમ જે છે એ થ્રુ આઉટ સેમ હોવી જોઈએ. કોઈ બી જગ્યાએ જ્યાં આખી લેન્થમાં જે લેસિંગ પ્રોવાઈડ કર્યું હોય ક્યાંય બી વેરી ના થવું જોઈએ. ડિસ્ટન્સ ટુ ડિસ્ટન્સ બધામાં સેમ હોવું જોઈએ, રાઈટ? So next is cross or acceptable type lace should not be provided along the length of the column with lacing system unless all the forces resulting from deformation of column members, right, which is calculated. The single lace system on opposite side of the main component should be preferably be in the same direction so that the one system is the shadow of the other. So laced compression members should be provided with tie plates at the end of the lacing systems. And at the points where the lacing systems are interrupted, the tie plate should be designed by the same method as followed for battens. So there are some basic design requirements for lacing, how to design a lacing system, right? So first one is the angle of inclination, which is denoted by theta, which is provided in clause number 7.6.4, which is for single or double lacing system. So whenever theta is equal to 40 degree to 70 degree to the axis of the built-up member, normally taken is equal to 45 degree, right? Next is slenderness ratio. Slenderness ratio is denoted by KL by R and is represented in clause number 7.6.5.1. So KL by R for each component of column should not be greater than 50 or KL by R not greater than so that the it is 0.7 multiplied by most favorable slenderness ratio of the member as a whole. So the slenderness ratio of lacing should not exceed 145, which is included in clause number 7.6.6.3. The next one is effective length of lacing, which is denoted by LE. For bolted connection, in bolted connection, there are two for single lacing. Effective length LE is equal to L, and for double lacing, LE is equal to 0.7 L, where capital L is equal to distance between inner and fasteners. So that in welded connection, effective length, which is LE, is equal to 0.7 multiplied by distance between the inner ends of the welds, right? Here alls are provided, right? Here column component is provided, lacing system is provided, right? So here angle of inclination theta is described in this. Theta is equal to angle of inclination, right? So that width of lacing bar, which is B, is equal to minimum width of lacing bar, B is equal to 3D. This criteria is fixed, right? Whenever you need width, find out the width of lacing bar, we taken as is equal to 3D, where D is equal to nominal diameter of bolt, which is connecting two lacing system by a bolted connection, right? Thickness of lacing, which is denoted by T, which is provided in clause number 7.6.3. For single listening, thickness will be greater than LE divided by 40, and for double listening, thickness greater than LE divided by 60. Next is transverse shear, which is denoted by VT, given in clause number 7.6.6.1. This force shall be divided equally among the lacing systems in a parallel plane. So for double lacing, F is equal to VT divided by 4 sine theta, where VT is equal to 2.5% of the axial force in the column. Now next is different types of checks, right? Seventh one is a check for compression strength. Either it's capable of designing this compression is a compressive load carrying capacity or not, right? So for lacing system using LE by R minimum and Fy is equal to 250 MBA, find out FCD from IS 800 table number 9C, right? Which we will learn earlier, right, in compression member, right? So here we find out compressive strength. So for compressive strength, we will go in the design of compression members, right? So for rectangle section, buckling class is C. Hence, compressive load carrying capacity of lacing is equal PD is equal to PD, which represent compressive load, which is equal to B multiplied by T multiplied by FCD. B multiplied by T represented area of the lacing, right? If design compressive load which is greater than the given load, then our design is okay. And if B cross T cross FCD, this equation is greater than F, right? Given force is also then okay, right? So our our design lacing system is okay for uh, practical use, right? Next one is a check for tensile strength. So for checking of tensile strength, we calculated some examples in a tension members, right? So for that, uh, tensile strength of lacing flat TD is equal to 0.9 in bracket B minus T multiplied by T multiplied by Fu divided by gamma, or Fy multiplied by Ag divided by gamma M0, which is given equation in tension design of tension member, right? So whichever is less, so taken as this either taken as this condition or this condition, whichever in both equation are less, we will taken it, right? So if this TD which is greater than the given force is, then our tensile strength is okay, right? So lacing is also checking for compressive strength, also check for tensile strength. Now next is end connection, which is given in IS 800 clause number 6.3.1 page number 32. For case 1, which is a resultant on force on bolt, which is R is equal to F, in which number of bolt required is equal to F divided by bolt value. For the second case, resultant of force on bolt taken as R is equal to 2F cos theta. So number of bolt required is equal to 2F cos theta divided by its bolt value. So strength of bolt in bearing equation is 2.5 kb multiplied by D by multiplied by T multiplied by F, which is given in clause number 10.3.4. Right. So here two different cases are given. First one is two lacing flats connected separately, and the second case is two lacing flats connected at one point. So this end connection for case 1 and case B is for that, is for here, right? So case 1 is connected separately, and second case is connected at one point. So our 10th equation is overlap. So in case of welded connection, the amount of overlap measured along either edge of lacing bar shall not be less than 4 times the thickness of the lacing bar or the thickness of the element of main member. So taken whichever is less, right? So this one is our overlap condition. So this 10 criteria satisfied during the design of lacing system. આ બધા જ ક્રાઇટેરિયા તમારે યાદ રાખવાના છે, રાઈટ? તો next one is battening, right? So battening, what is meaning of battening? So it is described in this figure, right? So compression member can also build up intermediate horizontal connecting plates or angle connecting two or four elements of column. So these horizontal connecting plates are called as battens. So number of battens shall be such that the member is divided into not less than 3 bays within the actual length, right? So generally compression member can also be built up section immediate horizontal connecting plates or angle connecting two or four elements, as you shown figure 1, 2, 3, 4, right? There are four elements of columns. So the batten shall be placed opposite to each other at each end of the member and at a point where the member is stayed in its length as far as practicable be spaced and proportions uniformly throughout. So number of battens shall be such that the member is divided into not less than 3 bays within its actual length. So next we going is a design requirement for battening. What are the design requirement for battening? So here one case is given, right? So there are two columns given. Center is provided with battens which is fixed in this column, right? So in IS 800 clause number 7.2.2 in page number 51, first criteria is number of battens shall be such that the member is divided into not less than 3 bays. Second criteria is batten shall be designed to resist simultaneous. So the longitudinal shear dV is equal to Vt multiplied by C divided by Ns, and moment M is equal to Vt multiplied by C divided by 2N, where Vt is equal to transverse shear force, C represented as the distance between center to centers of battens longitudinally. Like here, this all criteria is given in this figure. N is equal to number of parallel planes of battens. Usually there are two, right? S is equal to minimum transverse distance between the centroid of bolt or rivet group. S is given center to center distance, right? Third criteria is slenderness ratio, which is given in clause number 7.7.1.4. The effective slenderness ratio KL by R multiplied by E of batten column shall be taken as 1.1 times the KL by R multiplied by O, so that the maximum actual slenderness ratio of the column to account for shear deformation effects. Fourth one is the spacing of battens, which is denoted by C, which is given in clause number 7.7.3. So in that case, C by R minimum for any component of column should not be greater than 50. And the second one is if C by R minimum should not greater than 0.7 multiplied by KL by R or any built up columns, right, about ZZ axis. Fifth criteria is thickness of batten represented as a T and provided in clause number 7.7.2.4. So in that case, T, which is thickness of battens, which is greater than LB divided by 50, where LB is equal to distance between the innermost connecting line of boards, which is perpendicular to the main members, right? Next, sixth criteria is effective depth of battens, which is DE, which is provided in given in the code clause number 7.7.2.3 for intermediate battens DE, which is greater than 3 by 4 multiplied by A. For n batten DE, which is greater than A, for any batten DE greater than 2B, where DE is equal to effective depth of battens, which is distance between outermost bolts longitudinally, right? Which in which A is equal to distance between centroid of the main members and B is equal to width of the one member. So overall depth of batten D is equal to DE plus 2 multiplied by n distance. Next is transverse shear, which is a VT, and given in clause number 7.7.2.1, where VT is equal to 2.5% of factor axial column load. Next is overlap, which is given in 7.7.4.1. For valid connection, the overlap shall not be less than 4 times the thickness of the batten plate. So it should be noted that the batten columns have least resistance to shear compared to column with lacings. And the last criteria is minimum thickness, and the other this is for this all are the requirements of battening system. Now minimum thickness of slab base is minimum thickness of rectangular slab base supporting columns under axial compression cell beam. Equation is Ts is equal to under root of 2.5 W A2 minus 0.3 B2 gamma m0 divided by Fi, which is greater than Tf, where Ts is equal to thickness of slab base, W is equal to uniform pressure below the base, AB is equal to larger and smaller projection respectively of the slab base beyond the column, and Tf is equal to flange thickness of compression member. So these all are the basic design criteria of lacing, battening, and slab base. So in the next lecture, we will discuss about, we will calculate the example of this uh, these requirements, right? So we end this lecture here.